Alright, this is Mr. Sitta, Honors Chemistry. I'm going to put up an alternate thermochemistry review as a practice test tomorrow on Thursday, and I'll post this as a solution to it. A little more simpler. Okay. Describe the kinetic energy of an 80-gram bullet at 300. So you got a velocity and you got a mass. And Ke is an equation equals 1/2 mv squared. The only thing that'll kick you on this is you need SI units. And when it comes to mass, your SI unit is the kilogram. So for this problem, you got to take your 80 grams and convert grams to kilograms by dividing it by 1,000. And if you consider that tricky, you just need to use SI units. So your bullet ends up being 0.08 kilograms. You're just going to plug it into 1/2 times 0.08 kilograms, and then the speed was 300 meters per second squared. Okay, so 300 squared times 0.08 divided by 2, I get 3,600. So the kinetic energy equals 3,600. Your units are kilograms per meter squared per second squared. That unit is also known as a joule. A joule is a kilogram per meter squared per second squared. So there's your units in joules. And 3.60 times 10 to the third is 3,600. So I could write that as 3.6 times 10 to the third. So they give it to you in SI. Everyone should know that work equals force times distance. Which of the following is an exothermic process? That means this process puts heat out. Okay. To melt ice, you have to put heat into the system. So melting ice is endothermic. Evaporating water, you have to put heat in the system to make water go from a liquid to a gas, so that's endothermic. If you're boiling soup, you're putting heat into the soup system, so that's endothermic. When water goes from a liquid, from a gas down to a liquid, the gas is at higher energy, the liquid's at lower energy, so that's going to put out heat, okay, when water condenses. And when your temperature's dropping, that's endothermic. So E is endothermic. So the only one that's exothermic is D. Okay, we should definitely know this. This is going to be all over the test. If you are negative, you're exothermic. If your delta H is positive, you're endothermic. So I'm looking for negative with exo, and that corresponds to B. Okay, a chemical reaction that absorbs heat from the sounding is said to be, that's endothermic, and its value should be plus. So I'm looking for endothermic and positive. Okay, the reaction shown above, you got a negative delta H, and so the process is exothermic. And an exothermic heat is evolved. The word evolved means to put out, okay, which is an exo. Absorbed would be endothermic. Okay. One of the reasons I'm doing this is the last sheet, when I was taping it, it kind of shifted, so when I looked at it, I can't really see when I'm taping, but the sheet was out of line, so you couldn't see the sheet as I was doing it. Okay, how much heat is evolved? So I want Kj on the right. I'm starting with 2 moles of NaOH. And I'm going to use delta H as a conversion factor. Now if I write this as a thermochem expression, I'm going to say there's 126 kJs liberated on the left. And the negative sign just tells me that it goes on the right. and I can convert from moles to kJs. 126 moles. Now, the important thing is, it doesn't say kJ per mole, it just says kJ. When you look at a thermochem equation, it's per 1 mole of oxygen, it's the coefficient, you look at each one separately, it's per 4 moles of sodium hydroxide, per 2 moles of water, and per 2 moles of sodium peroxide. And so we're looking at the NaOH, so it's going to be per 4. So it's going to be half of whatever it is, and I'd say that's going to be 63 kJs. Okay. The value for this reaction is 126. It's negative, so again, I'm going to write it as a thermochemical equation. And I want to convert to kJs. I'm now going to start with grams, 25.0 grams, but this time sodium peroxide. So I want to go from a gram to a mole. Okay, I need the molar mass of sodium peroxide, so 2 times 23 is 46. 2 for oxygen, 2 times 16, 32. So the molar mass is 78.0 grams per mole. So 78 grams per mole. Now make sure you label, because this is where people will blow it on these. I need to go from moles, and I want to go from Na2O2 to kJs. Well, in the last problem, I was using 126 to 4 because I was going to NaOH. For this problem, I'm going to the peroxide. And the conversion factor is 2. Peroxides give me 126 heat. So it's got, every time you use delta H in an equation, it depends on which reactant or which product you're trying to convert from. So it changes all the time, divided by 78. Molar mass is always per 1, and that's what will screw people up. If you're used to saying grams per 1 mole, well, when you do kJs, this is always your coefficient, unlike molar mass, which is always 1. So times 126 divided by 2, 20.2. The answer is A. Okay. Now, same thing, I'm converting the kJs. Okay. And at this point, I could put a negative sign on these and say that the kJs negative means it's released. But in the equation, I'm asking you which one is evolved. So I'm already telling you that it's exothermic and it's released. So I can look at the change in the amount of heat, the Q, and these are all Qs. I can look at that as just an absolute value problem, how much is coming out, how much is going in. But if I wanted to denote it, I would put negatives in front of these, and that would say that they're being evolved. All right. This one says what's the enthalpy change, but it doesn't ask you. So I want to use a sign on this one, actually. And I tend to stay away from using signs on these, because if I reverse the reactions, you get negatives for moles and grams, which you can't have. So if I ask you for grams, it's never really going to have a sign. Okay, we got 0.95 grams of sulfur. So we're going to go from a gram of sulfur to a mole, and sulfur is 32.06 or 32.1. This is sulfur. Now a mole of sulfur to kJ. Now normally I wouldn't put the sign in because they're just asking for the change. I'm going to put in the negative, 790. And for sulfur, it's odd because, yeah, it's not showing you the reaction. Oh, here it is. Bad eyesight. Lights in my eyes. Per 2. And now for this reaction, this is also exothermic, so I'm putting my 790 kJs here. But because it asked me enthalpy change and not evolved, I'm actually going to put a negative sign on it because it's exothermic. So 0.95 divided by 32.06 times 790 divided by 2. And the answer, 2 sig figs, is 12, and it's going to be negative. That just means you're exothermic. that comes from you knowing that that's a negative, so the answer is going to be negative 12. Okay. So far everything's just keeps going grams, kj's to grams, but I can go from kj's to grams. Okay, I'm going to combust 16 grams of benzene C6H6. Again, this reaction's exothermic, so it's plus 6535 kJs. I'm asking again, are evolved? So I want to go from a gram to a mole for benzene. And benzene is 78 grams per mole. 12 times 6 is 72 plus 6 is 78. C6H6. A mole to a kJ. 6535 kJs is equivalent to 2 moles of benzene. The 2 comes from the coefficient. So I got 16 divided by 78 times 6535 divided by 2, and the answer is 670. Okay. Determine the amount of heat. Again, let's go into kJs. I can turn this around. It's starting to bug me now. 12 grams of CO2, carbon monoxide. So I'm after that carbon monoxide right there. You want to go grams to moles. It's 12 plus 16. So it's 28 to 1 for CO. I want to go from a mole of CO, which is 2 moles of CO, to a kJ, and again, they're all exothermic, plus 482. And it says exchanged with the surroundings. So it's not really, I don't really have to say the sign, I can just say the absolute value. 482 kJs. 12 divided by 28 times 482 divided by 2. 103 is exchanged. And again, there's no negative sign on that because it didn't really ask you whether it's coming or going. Okay. Number 12. Now, I don't really specify this, but we are going into Hess's law. I give you reaction, and then I give you the same reaction, but everything's doubled. So what I want to do is just double the heat. So the answer is going to be 0.967. Okay. How much heat is traveled when this is produced? Okay. This is more dimensional analysis, kJs. And I haven't come up with any calorimetry problems. When I use the equation Q equals Cp times M times delta T, I'll make one statement right here. I will use this equation if I see 2 temperatures. So delta T is when it tells you to use this equation. So you haven't seen any problems which ask you for a temperature change yet. But that's calorimetry when you get there. We're not there yet. 5.75 grams of barium hydroxide or barium oxide. Okay, so I need to go from a gram to a mole to a kilogram. So the delta H is 1107 per every 2. The molar mass is 137 plus 16 plus 16, 153.3 to 1. So we got 5.75 divided by 153.3 times 1107, 41.5. Something doesn't look, did I divide that by 2? Probably not. 5.75 divided by 153.3 times 1107, and I got to divide by 2, which I forgot to do. 20.8 C. Okay. Honestly, on this worksheet, I would have at least liked to do one where I go from kJs back to grams, and that's one of the reasons I avoid using positive and negative. I suppose if you stay with the signs, it'll come out. Okay. heat capacity of lead, that's your CP, equals 0.13 joule per gram per Kelvin. Interesting, they put Kelvin in there. That is a change in temperature. Kelvin's the same temperature change as Celsius, so it doesn't matter whether you use Kelvin or Celsius. The mass is equal to 15 grams, and the delta T is the T final is 37 minus 22. So your delta T is 15 degrees. So I want the heat, the Q. So I'm going to use the calorimetry equation, Cp times m times delta T. So I got, okay, they weren't asking for Cp, they're asking for Q. So I got 0.13 joules per gram per K times 15 grams. And this temperature, 15 degrees, is the same as 15K. So all I have to do is multiply. And the answer is 29 joules. Alright, I'm going to do another tape. I don't want it to go too long.